Now, students, as we have to understand velocity and acceleration, we need to understand these expressions. If we do not understand these expressions, we won't be able to find velocity and acceleration. Before that, let me start with something very easy that you all have seen. Now, you all have seen this type of equation. Let me draw the line. This type of equation you have seen in class 8, 9th or something like that. Y is a function, this ax square plus bx plus c, I mean to say this type of, where x is given as minus b plus minus under root b square minus 4ac by 2a. This was a quadratic equation in class 8, 9th, and you have seen the solution like this. Here, y is a function of x, where x is independent variable, where x is independent. Wait a minute. Hmm, X is an independent variable, and y is a, let us call it IV, independent variable, shortcut, and this is a dependent variable. Oh, wait a minute. Let me write it a little clearly. Variable. Oh, just a minute. Now it's okay. Now the thing is, why this is dependent and why this is independent. Now you put, let us take an example. Let us take an example. Suppose I write y is equal to x square plus x plus 1. Now x I take as 0. Then y will be 0 square plus 0 plus 1 is 1. X, I take any value of x. I take x equal to 1. So y equal to 1 square plus 1, that is equal to 3. So depending on the value of x, you are getting y. That's why x is independent and y is dependent variable. Now you need to understand the calculus that is involved in physics. Later on we'll do it in maths, but basically this we have to do it right now. What is ds dt? What is dv dt? These all concepts needs to be understood. Let me take some page. Okay. Let me. Oh wait a minute. Okay. Now you have seen in class 10th that if there is a circle, there is only one point which is a tangent to the circle. The tangent touches at a single point on the circle. This is the point where it touches. Now see, what is, I'm trying to make you understand what is, first I'll make you understand what is dx, dy by dx. What is dy by dx? Already this is your x-axis and this is your y-axis. Later on I will convert it into ds dt and all that stuff. First we will understand this concept. Understand this concept first. Then we will understand this concept. Very simple it is. After that it is very, very simple. Now let us see one thing. Before I do anything, x is, let us take x as, this is your number line, this is 0, this is 0.000000001, and this point is minus 0.000000001. I don't know how many zeros. Now when I say x tends to 0, it does not mean it does not, wait a minute, it it does not mean x is 0. Does not mean x is 0. X may be 0.000000001, or x may be minus 0.0000000, what I've written it here, 0.00001. In these both cases, I can take, x can be taken as 0. That is, you can put x equal to 0, but x is not 0 basically. This means, this means x tends to 0. This means x tends to 0. First, you understand this concept of tending to, this concept. Next concept. The next concept that I need to tell you is this. Wait. Now I need to tell you this. Suppose you have this x and y coordinate. This is your x coordinate, this is your y coordinate. This is a curve of some part. This is a line cutting this curve somewhere. This point is x2, y2. This point is x1, y1. x1, y1. I draw this line, I draw this line, I draw this dotted line, I draw this dotted line. Now, this change, this much portion is, this much is y1, this whole portion is y2, and this much portion is y2 minus y1. Similarly, this one is x1, this one is x2, therefore this portion is x2 minus x1. Now this is a finite change as x2 minus x1 and y2 minus y1 are finite change. So we can write del x as x2 minus x1 and del y as y2 minus y1. Now come to the point. This angle is theta, tan theta. This angle is tan theta. Let me draw the line this way now. This much portion, and this much portion. I'm talking of this much portion only. Now tan theta as in class 10th you know, perpendicular over base, the y2 minus y1 over x2 minus x1. That is same as delta y upon delta x. Now this is now let me draw the line, take a little bit more page. When this, let me go back, wait a minute, let me go back. When this point approaches this point, it is somewhere very small. That means when delta x tends to 0, that means x2 minus x1 tends to 0. That means x2 tends to x1. So the difference between this point and this point, x1, y1, this point A and this point B, becomes so less that we can consider that tan theta when A approaches B, point A approaches point B. In that case, the limit delta x tends to 0. This idea, d, sorry, this becomes delta y upon delta x becomes dy by dx. That is this difference is actually infinitely small value, infinitely small case. When this becomes infinitely small, this whole thing becomes dy by dx. Let us do one or two problems. Before that, let me give you the formula of derivatives so that wait a minute, so that now the list of formulas that you need. I hope you understood this why this dy by dx. Now similarly, instead of x you write s, and instead of y you write s, and instead of x you write t. Then dy by dx ends up becoming ds dt. This is nothing but velocity. The idea comes from here. That's why I use the y and the x axis. Then instead of a y and the x axis, you can use the s and the t axis. one and the same thing. This is just a matter of name. This is the y-axis. Y-axis goes become can you can make it s-axis, and x-axis can be made into t-axis. Then instead of dy by dx, you will get ds dt. The idea is same. Now let us write down the formulas needed. Derivative formulas. Number one, d of dt t to the power of n is nt n minus 1. Second, d of dt e to the power of t is e to the power of t. Third, d of dt of sine t is cos t. Fourth, d of dt cos t is minus sine t, right? Next, next, the fifth formula, d of dt of tan t is sec square t. Sixth formula, d of dt of cot t is minus cosec square t. Seventh formula, d of dt of log x, log t, let me say, 1 upon t. Seventh, eighth, I think this is d of dt of, I think now, cosec x, cosec t is minus cosec t, tan t, cot t, sorry, cot t. Ninth, d of dt of sec t is nothing but sec t tan t. This mainly we will be needing, this formula most of the time. This is very, very important for you all. We will now do some problems on this. Now, let us see how to do these problems. How to do it. Let me take an example. Let me take an example. Let me take an example. Now, let S be equal to 5t square plus 7t plus 6. Also, one more thing I forgot to tell you on the top is you need to write the 10th one. The 10th one is ddt of constant is equal to 0. Now, you want to find velocity. Velocity is ds dt. So you do this ddt, put the value of s in the whole thing, 5t square plus 7t plus 6. Now this is a constant, take it out. 5 ddt of t square. This is a constant, 7 is a constant, take it out. ddt of t and ddt of 6 being a constant according to this rule will be 0. So this is 5. Now this is, we will be using, I'll take some more page, wait, to make you understand. I'll take some more page, wait. Now we just did this formula. Ddt of t to the power of n is nt n minus 1. We did this formula right now on the first formula. We will use this. Now this v will be equal to 5 t square will be 2 minus 1 using this formula plus 7 t to the power of 1 it is. So into 1 t to the power of 1 minus 0 plus constant, because this constant is 0. This is 5 to the 10. 10t, 2 minus 1 is 1 plus 7 into 1 is 7, t to the power of 0. So t to the power of 0, anything to the power of 0 is 1. So 10t plus 7. I hope you understood. The next. Now I want to find acceleration. Acceleration is dv dt. Now I will use this same d dt of 10t plus 7. This is going to become 10 is a constant, take it out. ddt of t plus ddt of 7. So this is 10 t to the power of 1. Use this formula. Use this formula. This formula. So 10 t to the power of 1 into 1 t 1 minus 1, and this is plus 0. Plus 0 because this is a constant. This is a constant. So this is equal to 10 into 1 is 1. T to the power of 0. This is nothing but 10. This is the way you will do it. And this is meter per second square, the unit. And this is whole thing is meter per second. The units also you need to write. Don't forget to write the units. Now I hope you have understood. Let me do two more problems with you guys. Two more problems with you. Yes, wait. Here we are. Now take 5t cube plus 7t square plus 6t plus 8. Now I want to find velocity. ds dt, I have the formula here. d dt of t to the power of n is nt n minus 1. I'll use this formula always. ddt, ds dt, this will become ddt of 5t cube plus 7t square plus 6t plus 8. Now this is going to become 5 will be a constant, ddt of t cube plus 7 ddt of t square plus 6 ddt of t plus ddt of 8. This is a constant. This will become 0. Use this formula. 5 into 3 t to the power of 3 minus 1 plus 7 into 2 t to the power of 2 minus 1 plus 6 into 1 t to the power of 1 minus 1 plus 0. Using this formula, let us take some more page. Yes, here it is. So velocity comes out, if I say the 15 t square plus 14 t plus 6 t to the power of 0 is 1. So this is my meter per second. Now I want to find acceleration. So dv dt, this is ddt of 15t square plus 14t plus 6. This will become 15 ddt of t square plus 14 ddt of t plus ddt of 6. This is now a constant and will become 0. So this is 15 into 2 t to the power of 2 minus 1 plus 14 into 1 into t to the power of 1 minus 1 plus 0. So this is going to become 30 t plus 14 meter per second square. So this is the way we find velocity and acceleration. Now you see, supposing acceleration is given to me and I want to find acceleration is given to me, I want to find the velocities and your distance. So what I'll do is that I'll give you the integration formulas now, or in the next lecture I'll give you okay, now in this lecture only I like to give you integral formulas. Integrals. First one, integral, this is the way you write. T to the power of n dt is t to the power of n plus 1 upon n plus 1 plus some constant c, n not equal to minus 1. Provided n is minus 1, then it becomes ddt of t, and this becomes log t plus some c. Similarly, e to the power of x dt, e to the power of t dt becomes e to the power of t plus some constant. This is 1, 2, 3. And this is the most important one, this two. Mostly we will be using this one. Then we have fourth, this is sine t, sine t dt is equal to minus cos t plus c. 5. Cos t dt is equal to sine t plus c. 6th, sec square t dt is equal to tan t plus c. Now I will do it here. Some page I'll take from here. I'll do it here. Seventh, cos x square t dt is equal to minus cot t plus c. 8. 8 is sec x sec t dt is nothing but log sec x sec t plus tan t. Tan t. Wait a minute. Let me write it properly. Wait a minute. This is log uh, sec t plus tan t plus c. And with this I'll give you some properties of logs also that are very very much important. Wait. Now here is the property of log. Log, see, in calculator, scientific calculator, since you people are in first semester scientific you are allowed to use scientific calculator in examination externals. Now there are two buttons in the calculator. One is ln, the other is log, just next to each other. This in calculator means log base 10, and this in calculator means log base natural. This means this. This is, I'm telling you because you people have just come from class 12th to BCA, and you are allowed to use scientific calculator. I'm telling you the difference in the these two buttons in the calculator. Now log a b is same as log b by log a. This is 1 upon log a by log b. This is equal to 1 upon log BAC. They change, then 1 upon they change. If these two are interchanged, then this becomes 1 upon the interchanged one. Number 1 point. Now, second, log A plus log B. Log B. This is log AB. Never write log A plus B is never like this, is never equal to this. Remember this. Never do this mistake. Next. Third, log A minus log B is equal to log A by B. Never write log A minus B is equal to this. This is never possible. Never possible. Fourth, log A to the power of M is M log A. Fifth, log A to the power of, say, B. Let me take it B. Wait a minute. Wait a minute. Let me take it B. B to the power of M. A to the, let me do it N here. It will be easier for you to understand. Wait. N, N. And let me write N. So this becomes log A to the power of N upon log B to the power of M. This is equal to N log A upon M log B. This is equal to N by M log B A. What I've done, I have used this. Wait. I have used this concept. This one. This concept. Here. This is written this much. Only this much. Only this much, not this. Let me write it down there, so that it is easier for you to understand. Wait. I'm using what I'm writing here. Log A by log B by formula is log BA. Now supposing, wait. Now supposing acceleration is given to me 6t square plus 7t plus 5. They are asking me velocity. They are asking me distance. S means I'm talking about distance. Now see this, how to do it. We will take the help of, we will take the help of this formula, this formula, this. This formula, we will take the help of this formula. Now, see, acceleration is dv dt. So this is 6t square plus 7t plus 5. We will take the help of which formula? T to the power of n dt is t to the power of n plus 1 upon n plus 1, where n is not equal to minus 1. So dv will be equal to, cross multiply both sides, 6t square plus 7t plus 5 dt, and take a integral sign both sides. Now you see one thing. Let me go down a little. Let me take some page. Wait. Okay. Now you see this. When this is dv, that means there is a 1 here automatically. That means there is a v to the power of 0 dv. Now you use this formula. V to the power of 0 dv is equal to v 0 plus 1 upon 1, 0 plus 1. That is nothing but v upon 1, and this is v. So this becomes v. This becomes 6 out, t square dt plus 7 t dt, constant is out, plus 5 dt. This time this will not become 0 because this is an integration. This is 6. Now t square will be t cube and by cube. So t, this is power 2 na? Wait. This is power 2. So power 2 is 2 plus 1 upon 2 plus 1. So this is 3 upon 3 plus 7t. Power is 1 here. So 1 plus 1 upon 1 plus 1. So that is 2 by 2 plus 5. There is nothing. It will behave exactly like this one. So t plus some constant c. Again, let us scroll down a bit. Let us scroll down a bit. Now I want to find distance. This is not speed. This is distance. I want to find dv dt. And this is 3 2s are. So 2t cube plus, because of this cancellation I got this, 7 by 2 t cube t square plus 5t plus some c constant. Okay, sorry, I made a mistake. Extremely sorry, I made a mistake. This is velocity and this is s. So now ds is equal to 2t cube plus, oh wait a minute, 2t cube plus 7 by 2 t square plus 5t plus c dt, put an integral sign, put an integral sign. As I did for dv, this will become s, this will become 2 t to the power of 4 by 4, because 3 plus 1 upon 3 plus 1. This is 7 by 2 common, d square dt it is. So t square, so this will become t cube into by 3, 5 t to the power of 1. So again let me write down the formula here so that you will always remember this formula. T to the power of n plus 1, n plus 1, n not equal to minus 1. So now it is t power 1, power 1 it is. So power 1, 1 plus 1 upon 1 plus 1, that is t square by 2. Now plus c, c has nothing, it will behave exactly like this. So ct plus c1, again a constant of integration. So this is my, let me finally bring it to a conclusion. So this is s is equal to t to the 4 by 2 plus 7 by 6 t cube plus 5 by 2 t square plus ct plus c1. This is the way we find both ways. From distance you can find the velocity and acceleration. From acceleration you can find velocity and distance. I did this example. Okay, thank you. We will do something in the next lecture. Fine.